are all that's being added to the mix now is the friction. So over on the right, can I just remind you of the key point? It's that you go and put those tension arrows pointing up towards the pulley. Okay. Once you've done that, you can then look at R in isolation. At P in isolation and Q in isolation. Okay. So when we look at P in isolation, over on the right in blue, I've started off by resolving perpendicular to the inclined plane. So the only forces in town are the green force and the orange force. F equals ma. There's no acceleration perpendicular to the plane, so we can work out what the normal reaction is. Once we know what the normal reaction is, still for P, still for particle P, the object on the inclined plane, we can then, secondly, which I've done in purple there, resolve along the plane in the direction of movement, which is up the plane. So again, left-hand side, F equals ma. Left-hand side, we've got the brown arrow, the tension going up the plane. We've got the component of weight in light blue going down the plane. And we've got the friction going down the plane, because of course friction is in the opposite direction to the movement. So that's our net force equaling ma, so 5a. And then we've substituted in what we know what r is from when we just resolved perpendicular to the plane, and that's allowed us to get an equation with t and a in it. Obviously we know g, 9.8. So with t and a, we then move over to looking at q in isolation. So q is the weight going over the pulley, and that's a much simpler set of forces. So resolving in the direction of motion, which is downwards, this is the bit I've done in red. Okay, so we've got that sort of light brown color going downwards, the 10g, the tension going upwards, that's our net force, and that equals 10a, and that's equation 2. Now remember, it's then just algebra, but it's a nice tip to go and add equation 1 to equation 2, because invariably you got tension being positive in one, being negative in the other. So that's a really quick way to eliminate the tension to allow you to work out what the acceleration is. And once you've worked out what the acceleration is, you can just substitute back in to find what the tension is. So that's just a quick summary of the first example. I didn't feel that the second example really added anything to the party. It's just got a few more angles in it. Okay, so I would like us to work through exercise 7F. It's a short exercise, so please could we try and do all the questions. I'm anticipating 2 lessons on this, okay, today and tomorrow. And obviously, if you do finish before the 2 lessons are up, please, that's it then. Please dot around the mix exercise. And I will aim to go and get the, for those of you who are really keen to keep bang up to date, I will aim to get the assignment on this week so that those of you who want to can try and get the second one done before we go into half term. Okay, so that's it. I'm just going to stop the recording.